For 240 years, the prestigious Budapest University of Technology and Economics has been a leader in higher education. On our campus, where tradition and modernity go hand in hand, our mission is to educate experts in the disciplines of technology, engineering, informatics, natural and social sciences, business, and management.
Dear Airspace 224 participants, I would like to welcome everyone here in the room and online. This conference is organized every second year by the Budapest University of Technology and Economics and the Hungarian Astronautical Society. My name is László Bacsárdi. I work as an associate professor here at BME, and I'm also the vice president of the Hungarian Astronautical Society MANT. As the co-chair of the organizing committee, I have the honor to be the master of the opening ceremony today. I would like to invite three distinguished guests to join me, starting with Mr. Bálint Borsos from the Department for Space Activities at the Ministry of Foreign Affairs and Trade. Dr. Eszter Udvary Gerhátné, Vice Dean for International Relations at the Faculty of Electrical Engineering and Informatics. And Dr. Kálmán, the President of the Hungarian Astronautical Society. I would like to invite Mr. Bálint Borsos to make his opening speech.
Thank you. Dear esteemed guests, fellow colleagues and fellow space enthusiasts, on behalf of Minister Commissioner Dr. Orsolya Meier, I would like to thank you for the invitation for this event. Also, she sends her regrets not being able to attend the conference. In the name of the Ministry of Foreign Affairs and Trade and the Department for Space Activities and Space Policy, I would like to welcome everyone, both in person and in online, to this event. And I'd like to convey Minister Commissioner's thanks and congratulations for hosting and organizing this event. Hungary itself, I think, have a rare and long history of almost 80 years in space research. Given the size of our nation, it is really hard, almost impossible to cooperate internationally alone and to do space research alone without our international partners. This is why we represent ourselves in the European Space Agency and the European Union, the USPA, and the United Nations. And we almost have 20 and more to come international cooperation agreements with governments and institutes. Space research itself and the topic of this event has a really high resonance with the Hungarian space strategy by echoing the endeavoring commitment of fostering capabilities and by dedicated investments into space research and education in Hungary. It's enough to mention the Unispace program, which gathers several universities all around the country to educate professionals in the space domain. These kind of university projects helps students and professionals or provides them an early knowledge of this space domain, and therefore they can gain knowledge and experience, and they can apply these knowledge and experiences into real projects and cooperations. We are extremely happy to see more and more universities and institutes become a part of the European Space Agency, and they become a part of European space activities, student activities, and calls and proposals. I think that this is a way that they realize that how essential it is to be a part of the European space domain through the European Space Agency. Also, the USPA has an emerging importance in the European space domain. It is, I think that it allows us to have a closer cooperation and international cooperation among the European Union member states, and it has become really highlighted. It has become really highlighted and will become even more highlighted during the Hungarian presidency of the second half of this year. So once again, I would like to thank you for the invitation, and I'd like to welcome everyone. And let's make the most of the Age Space 2024. And I wish you a useful and a fruitful conference. Thank you.
Thank you very much, Mr. Borsos. We are really grateful for the support from the Department of Space Activities. They are continuously support our conference. Since this conference is hosted by the Budapest University of Technology and Economics, now I would like to give the floor to Dr. Eszter Udvary to make her opening speech.
Thank you, László. I would like to welcome everyone at the Budapest University of Technology and Economics. We have a long cooperation with the Hungarian Astronautical Society, and I am happy that we can organize this Age Space conference series together. We are in the building I of the university at the Faculty of Electrical Engineering and Informatics. So I would like to forward the welcome of our Dean, Professor Hassan Sharaf. Unfortunately, he can not be with us this afternoon. As the Vice Dean for International Affairs, I glad to hear that the conference has about 180 participants from 18 countries. So it is really a big international conference. My congratulations, László. Actually, the faculty focuses on innovation, research, and education, similar to the Age Space 224 conference. And go back to the history, the first Hungarian satellite, Masat-1, was developed here at the university and launched in 2012. Since 2012, 4 other, even smaller satellites have been developed and launched successfully with the cooperation of our faculty members. And we partnered with Alba Orbital for launch of our PICO satellites. So I was glad to see in the program that there will be a keynote presentation by Mr. Reza this afternoon. Thank you for accepting our invitation. But not only satellites are developed by our faculty, we have 10 departments that carry out research in various domains, including artificial intelligence, autonomous vehicle communication, cyber security, Internet of Things, image processing, optical and quantum communication, software development, 5G and 6G mobile communication and networks, etc. Many of these research areas are close to the space sector or even well connected to it. So that's about the research, and as the leading technical university in Hungary, our important task is to train future engineers. In 2022, we started a new space-related education program, the Space Engineering Master Program, and the first class of Hungarian space engineers will graduate this June. When we created the program, we studied different international European master space programs. But we are always keen to learn from other universities. So we are honored that Jaan Praks from Aalto University accepted our invitation. Looking forward to listening to his insights. Moreover, we actively contribute to a nationwide educational program called Unispace, in which 16 Hungarian universities participate. Our university is responsible for the 3-semester-long space technology postgraduate program, in which we are collaborating with 10 Hungarian universities. And I am happy that I can say that the first class graduated at the beginning of this year, and we will start the program in English this semester. So, as a conclusion, I am happy that we can host this international event, and I wish you a successful conference. Thank you for your kind attention.
Thank you, Eszter. As member of the faculty, I always keen to listen to different activities that we have, so not only the space, but in other domains. And in my other hat as the Vice President of the Agnes Society, I'm happy that the university can host this event. And with that, I would like to ask the President of the Society, Dr. Kálmán Kovács, to officially open our conference.
Thank you, László. Dear audience, it was exactly 10 years ago, in the spring of 2014, that we were excited about the successful mission of the first Hungarian satellite, Masat-1, mentioned by the Deputy Dean, made by the Faculty of Electrical Engineering and Informatics at the BME. At that time, the requirement for PICO satellites to operate successfully was 3 months. But by 2014, Masat-1 was already past its 2nd year. So it was really understandable that we were very happy and very proud. In addition, the decision was made that Hungary, at that time the decision was that Hungary will become the member of the European Space Agency, ESA, from 2015, and we knew that our university research groups should also prepare for the new opportunities that would open up. Therefore, the Faculty of Electrical Engineering and Informatics, Information Technology took the initiative to unite the space research and space engineering activities at the university level. And we created the BME Space Forum with 12 departments from 5 faculties. One of the most important elements of our joint program was the launch of the H-Space, the International Conference Series on Research, Technology and Education of Space in 2015, together with the Hungarian Astronautical Society. The past decade has brought many Hungarian successes in the field of space activities, and the Space Age International Conference, the HASpace International Conference Series has been a very successful forum for the presentation of the latest results and the future plans of the research, space engineering, space applications, and space education as well. In the view of all these, it's a great pleasure and a real honor for me to be able to welcome you as a president, now as a president of the Hungarian Astronautical Society at the 8th H-Space Conference. As the president of MONT, let me share the recent success of the Hungarian space sector with you. Ivan Almár, astronomer, the hereditary honorary president of the Hungarian Astronautical Society, in recognition of his decades-long significant contribution to the development of the Hungarian and international space research, has been selected by the International Astronautical Association, IAF, as a member of IAF Hall of Fame. I think it's a really very huge result for the all Hungarian Space Society. All in all, I would like to thank the work for the organization editorial board and the chief of the board, Mr. László Bacsárdi, and I would like to thank the BME Cosmos College for the advanced studies, who help with the on-site organization, and the Galileo webcast for the online broadcast of the conference. Dear audience, hereby open the H-Space 2024. Based on the submitted abstract, I am sure that this year's conference will also be a very high quality, useful meeting. Thank you for your attention.
Thank you very much, and with that, the conference is officially open. Thank you very much for your speeches. And right now it's time to turn to the first keynote speech. This afternoon we will have 2 keynote speakers with us, and the first keynote talk will be by Dr. Jaan Praks from Aalto University. He is Associate Professor at Aalto University, School of Electrical Engineering, leader of Small Satellite and Microwave Remote Sensing Research Group at Aalto. He has strong experience in small satellites, remote sensing and science communication. Jaan Praks is a PI of several small satellite space missions, including the first Finnish satellite, the Aalto 1. His research team is working in Finnish Central of Excellence of Research of Sustainable Space, where the Finnish space missions for science are developed. Jaan has been involved in several Earth observation satellite spin-off companies, such as ISI, who is making remote sensing radar satellites, and Kuva Space, which is developing hyperspectral small satellites for future constellation. He is currently chairman of Finnish National Committee of International Union of Radio Science and member of the Finnish Committee on Space Research. Scientifically, Jaan Praks graduated as a doctor on space technology, namely radar remote sensing in 2012 from Aalto University. His publication list contains more than 100 publications on Earth observation and on space technology topics. But more importantly, he is the main person behind the Winter Satellite Workshop, the largest new space meeting in Finland, Scandinavia, and in the Baltic countries. So we are really happy that we can welcome Professor Praks here with us. The floor is yours.
Thank you, László, and it is a great pleasure to be here. I'm also revealing the small secret that this is my first trip to Hungary. I'm really glad to be here. It's a wonderful country. I have been having many friends already. I have already many Hungarian friends, but I haven't been able to visit them here before. So, I'm going to tell you a little story about our space activities. And first of all, I have to thank all of you for giving the inspiration also to Finnish satellites, because MASAT-1 was already a very famous project when we started to go around in CubeSat conferences and thinking about our own satellites, how to build them and what to do with them. So first, maybe a couple of words about my university, where I'm coming from. Finland, small country, only 5 million people, and Aalto University is one of the biggest technical universities in Finland, in the capital region. We are the second best university in Finland after Helsinki University, and the university is quite young. We were actually established as a merger of 3 different universities. It was the Helsinki University of Technology, Helsinki University of Art and Design, and Helsinki Business University. So we combining in our university technology, art and business, and the project name was Innovation University. We are especially keen in different kind of startup companies, patents, commercialization, and so on. Aalto University is the 3rd most patent application filing entity in Finland after 2 very big companies. So we are really trying to be as innovative as possible. But today I'm going to talk to you about space technology at our university in Finland, and more or less how it began, where we are today, and perhaps giving you a talk about where we could also maybe work together. Aalto University has a very small space program. We have just one major, which is called Space Science and Technology, and we do build small satellites. Aalto University has been already launching 4 satellites, and hopefully in the near future we are launching even more. But first of all, let's start with a story. Space is a very inspiring environment, and it's sort of easy to gather students around space topic. And we started actually very late. We started much later than most of the other countries, and this was our student laboratory of satellite development 2010, when we got the idea that we should also do something in terms of satellite building, because Finland didn't have yet a satellite for Finnish satellite. Although Finland has been the member of European Space Agency already from 1995, but no our own satellite. So I gathered the student team around the topic, because I was a young teacher at that time in our university, and I was handed a space technology course, so I needed to do something with it. So we started to see like what could be fun, and of course CubeSats were fun. And we started to fiddle with the idea, wrote during 2010, very beginning, a proposal about the space mission, a CubeSat, and started to also gather payloads around this proposal. First, we attracted students to the lab by pizza and fun, and later on we started to do like more serious work. The project lasted more than 5 years, actually 6-7 years altogether, and it was really difficult to like keep all these people around. But it was a kettle where a lot of people came in, went off, got inspired or got bored, and then they knew what they want to do. Are they wanting to do satellites in the future or not? Finally, our satellite was ready somewhere 2015-ish, 16-ish, because there was like different kind of exploration and problems with a ready satellite and so on. But nevertheless, we declared that our satellite is ready and we are ready for launch. Our satellite concept, it was a free CubeSat, was actually built around payloads which were acquired from other institutes. And I'm still very happy with this decision. So with this, we guaranteed that the mission is current, it's interesting, and it's also scientifically relevant. So these three different payloads were the Fabry-Perot spectrometer, a spectral imager which is smaller than anything else in this region or in spectral imaging, because the spectral filter is as big as the €2 coin. So it's really, really, really small. So you can see the spectrometer there. And the spectrometer was made by Finnish Technical Research Center, VTT. Then the second one was coming from Finnish Meteorological Institute, a very interesting instrument called Plasma Break, which is a Coulomb drug device for space, which we wanted to be the first to demonstrate. And then the radiation instrument, which was coming from University of Turku. And behind all of these payloads were really professional teams who have been researching these topics for like more than 10 years. And with this kind of knowledge in the mission, so the mission itself was built by students. The satellite was put together by students. And we had few commercial systems also. For example, the attitude system was a commercial one, which eventually didn't work at all. But nevertheless, we learned our lesson. But most of the satellite was actually built, designed, and done by students. And here it is. And first we were scheduled for a Sherpa mission, which should have been going to space with a Falcon 9 rocket, but this unfortunately was cancelled, delayed, and we were waiting a long time. And our satellite, for various reasons, was reintegrated to the deployment box for 5 times. So we went many times to Netherlands to reinstall the satellite, and the last times we were just already taking the Zoom connection when the guys from Netherlands were just putting it to another box. That was a long story why it happened. And finally we were also rescheduled because our ride, which we had bought from Easy Space, was sort of delayed to unknown future, and we got the launch finally with an Indian PSLV rocket in the midsummer day 2017, and Finland was the last nation around the neighbors to launch our own satellite. And of course the excitement was huge, and the risk was huge, and the responsibility was huge, because the radio we were building for another mission was not working properly in the previous mission, and we had no time to actually do many big changes and so on. But luckily the system worked, and our mission produced the first and proved the work also with the payloads, and produced the first scientific results. So we were able to show that this radiation monitor actually worked, and we captured a couple of interesting results, and we were able to write a couple of papers with University of Turku. We were taking the photos, and most importantly, we were also the first satellite which was demonstrating that this Fabry-Perot instrument was actually working in space, and we were getting the hyperspectral images. This hyperspectral imager became a very successful commercial product, or not only commercial product, but a scientific product, which has been nowadays adopted to many European Space Agency missions. For example, Comet Interceptor has this one on board, and Hera mission has one on board, and so on. So it really opened the gate for different kind of applications. And there was, during these projects, of course, huge amount of students who were getting excited and going through the project, doing important things. But even more than the satellite was valuable, especially these students and this excitement. Our project produced several startup companies. Because Finland was a small country with not very significant space technology branch, and especially what we didn't have was new space, small satellites. So there was like tens and tens of people graduating with a diploma like I can build small satellites, and nobody were building small satellites in Finland. Nobody was building satellites in Finland at all. So our graduates actually founded the first companies which started to build the small satellites. One of the most notable one is ICEYE from this bunch of people. So ICEYE was founded by these guys who were actually Aalto satellite engineers, and soon after 2 years of designing small CubeSat, they decided like, this is not enough. This is not nearly enough. We want to build much cooler satellites. And they participated a business course where they had to propose a business project which will change the world. And they, of course, they proposed as the satellite project, and they said like, Jaan, what is the really difficult thing to build? I said like, synthetic apparatus radar. We have never built one in Finland. It's really, really difficult to get. Yeah, we will build a synthetic apparatus radar. And so it became that ICEYE is nowadays the world leader of small satellites, radars. So ICEYE has been already launched over 30 satellites, both under flag of Finland and under the flag of United States. And their satellites are imaging with a 3-centimeter wavelength and are able to penetrate clouds and seeing during the nights and dust and combat and whatnot. And they are also the first company who was demonstrating from space a video imaging with a synthetic apparatus radar with a high resolution. So their first images were like 2 meters, 3 meters. Now they are already imaging with a less than half a meter resolution. So they are really, really accurate images, and they are able to provide every 8-10 hours an image from almost anywhere in the world with their tens of satellites in orbit at the moment. The company is located still at our campus area. They have been attracting already more than 400 million of its investments. The valuation of the company is more than $1 billion. It's a unicorn, and the company was actually founded in 2014, and they became the world leader of this kind of technology. And you can imagine that this is also very appealing and important in that times like we have, because they can see anything which is moving on the oceans, in the forest, on the desert, anywhere with a really, really short notice. But they were not the only company. Kuva Space was a company which actually took our satellite platform technology IPR and started to develop another project, which is a hyperspectral satellite constellation. And at the moment, they are designing, launching this summer their first demonstration. Actually, the first demonstration mission is already done, but now they are demonstrating a bit better capability with hyperspectral imaging from orbit with 100 satellites. And they also had last summer a very successful investment round. They have around 20 million to play with to their first missions, and hopefully they are able to repeat this service vertical development like ICEYE did. Another very interesting company was or is Arctic Astronautics. And Arctic Astronautics took a very different road on satellites, and what they started to build was an educational satellite. So they produced a satellite kit which is called KitSat, which they are selling for all the universities and high schools around the world in order to build their satellite-based education. They have not only the satellite, but also the whole program and all the slides and everything, how to do it. And they are not only selling the educational satellite kits around the world, but they are also developing a mission which is called VISA-WOODSAT. And VISA-WOODSAT is a very interesting satellite because they plan to make part of the satellite out of plywood. So it's a wooden satellite. So, of course, if you are coming from land of forest, from Finland, what you have to do is build a wooden satellite. Yet another company called Aurora Propulsion Technologies is building very tiny propulsion devices and also the deorbiting devices for these kind of very small satellite missions. We know space debris is a problem, space sustainability is really important, and they are the commercializer of the same plasma brake technology which was on board of our small first R1 satellite. Although we were not able to demonstrate the actual technology, and their first mission was also unsuccessful, but eventually will demonstrate that this technology works and will bring satellites down with a Coulomb force, which is an excellent choice for deorbiting because it doesn't have any physical area for causing the drag. It uses electrical field to cause the drag. That means it cannot collide with other satellites because of the bigger area. Then there was also many other satellite missions, mainly Kuva Space, which was originally with the name of Reactor Space Lab, developed together with different other institutes, several Finnish small science and technology demonstration missions. And we started to have already many and many small satellites. What did we learn about all this nice journey? I would like to point out a couple of things for you. Of course, you can catch my button anywhere in the corridor later on and ask me about the experience. But first of all, the first project is the first project. If you have a really exceptional project, you are also getting a really exceptional students. And it's very difficult later on to repeat this, but it really stirs the student community and you get like really interesting things happening. So universities should be really more doing something unexpected, something new, because these are bringing the additional value. Also, we learned that this kind of project needs a laboratory, needs a home. Students need a place where to mess around and attach their dreams to. Otherwise, it's not working out. It's not possible to make such a project when students don't have their own corner for this project. Another problem is that students are flowing fast. I mean, students come sometimes for only 2 months, but it doesn't mean that they are not excited about space. Their career can still be in space and they can be really excited. But it's just in this phase of life, everything happens very fast. And even a small exposure to something interesting might change your life. Documentation, everybody knows, of course, documentation is hard, it's boring, but it's the crucial part. And I cannot stress enough like how much you should push your documentation as a teacher or leader of the project in order to capture even small amount of this accumulating knowledge what you have. Timing is crucial, of course, in order to like get successful project, get successful outcome. Luck is needed, and the project will need money. And usually the micromanagement doesn't work, especially in this first project. The best approach is like get students, get money, get your home base and let it boil. Give the money to students and they will build your satellite. During this journey, we also learned that this is like, these breakthroughs are changing your environment a lot. So we were launching our first satellite without any like legislation in Finland in place. But soon also the parliament was catching up and the first space legislation, space law was made. And nowadays it's much more difficult to actually make small satellites fly because every satellite needs a permission, which is quite expensive. Every satellite ground station needs a permission, which is also quite expensive. And overall, the whole area, export, import, everything starts to be very regulated, and it's not easy to start anymore with just a small satellite. Although we are now established in the field, we know how to do it, but I don't believe that the true newcomer would start this kind of project nowadays. But we also were causing sort of the first excitement, the first companies and the first funding programs in this area, which was great. A couple of notes about the startups. So startup birth is always very messy, and yeah, you should just agree with it. This is a fact. And students are jealous about their ideas, but at the same time, somebody should collect the IPR, sort of like who is owning your designs. And it should be the university, because only the university has the credibility in the face of your investors. Otherwise, you cannot do it. And also, a lot of students who are starting at the university, creating companies, they say like, yeah, money is coming to the university, let's sell our stuff to university. No. You should teach to your students that university cannot be your client. And if you deal with universities for necessity, take it into account that universities are really bad clients. They don't have money, they whine, they are like not in time, and so on and so on. So don't sell to universities. Look for markets. And work with your investors and the markets from the first day of the project, because this is what is going to pay off for you. We also learned that combining this kind of very challenging project with actual teaching is very challenging because of all the previously mentioned facts and some others as well. Nevertheless, we really tried, and we actually have combined as a voluntary part of teaching our CubeSat activities. We have been developing a timeline system and the management system and the documentation system and the collaborative assessment system and so on. And nowadays we are running our student project with this concept. We also took a step towards the science, and we are now part of the Finnish Center of Excellence in Space, Science and Technology. And what we do is building demanding or more demanding science projects in order to validate the models. So space physics models are very advanced, and we have nearly not nearly enough measurements to validate these models, and therefore cheap satellites with a lot of measurements are needed. And our first satellite, Forcell 1, is having a telescope system for particles and another version of plasma brake system, which is the Coulomb drag device. And here you can see a couple of pictures how this satellite is built. So my team is one of the few teams who is building entire satellite from scratch. So we do the electronics design, we are creating even the sensors ourselves, we are also doing all the programming ourselves, ground station programming, everything is done by students. And here you have the payloads. We also do the CAD design and electronics design and install all the parts into the satellite concept, which we also have been creating ourselves. And this is Forcell 1 satellite, a science satellite for Finnish Center of Excellence. Here you can see the satellite itself. And the satellite was launched 2022 with a Falcon 9 rocket from United States. Unfortunately, the satellite was living only 2 months, and we are now working on the replacement satellite, which is based on exactly the same design but has several kind of improvements. We have been developing a new CubeSat-friendly, fully error-corrected, multi-channel radio protocol for CubeSats. This is open standard for everybody. We are gladly work together with all the CubeSats team in the world. We have been developing an S-band receiver because UHF, VHF starts to be very, very tricky. We are working with the magnetic devices and measurements on board of the satellites because we want to go to the higher orbits where is also a lot of more radiation, and we are also working with COTS electronic radiation in order to go to the higher orbit with Forcell 2 mission, which at the moment has no date for delivery, but we would like to go to the GTO orbit, stationary transfer orbit, in order to show that ULF, ultra-low frequency waves in the magnetosphere, are linked in a certain way with particle fluxes. Additionally, with these projects, we have also many other projects. We are working together with the European Space Agency, designing new low Earth orbit navigation systems, working with other projects with other universities in Finland to help them to develop satellites. And I think that the sustainable future requires space technology, and also small countries can have a significant impact on that. And therefore, I really would encourage everybody to stay in the field and give the contribution to the more sustainable world. And going a couple of tens of seconds over my time, I'm also inviting you to a conference. We also have similar type of conference in Finland. It's called Winter Satellite Workshop. This year in January we have more than 1,000 people already signed up, and this is a really fun 3-day conference. So go to the webpage, check what we have been doing, and next year in January I hope you to see all you in Finland. So thank you very much for your attention.
Thank you very much, Jaan, for this great presentation. We have time for a quick question from the audience. It's always hard to be the icebreaker and ask the first question at the conference.
One question, please. Don't let me down.
And after that, could you repeat the question for the records?
What was the method you used to motivate your students on a daily basis? Because my experience is really hard to motivate after the first few months, motivate the students to do the documentation, to actually come into the workshop and do some actual work. Everybody will just pass on the work or not do it. It's really hard.
Yeah. So the question was about how did I motivate the students and how it is possible to make these kind of things. There were two things which we were using. And first obvious thing was actually money. And Finland is an environment where a lot of master students are doing their master thesis with industry and they're getting paid to. In some countries this is not possible or even prohibited. In Finland it's totally normal practice and allowed. And what we did, we used part of the project money to hire students to do their thesis with us. And also we were hiring students who were active during the winter to get the summer positions. So they got the 3 months of salary, and they were able to sort of half-time do some things during the winter and then concentrate on these things in the summer. Additionally, I started as a professor in 2014 and I got my starting package, and I actually invested my starting package to students and especially doctoral students. It's really crucial to have some people throughout the entire project who know the systems engineering and know all the details of the stuff. They are not able to do everything by themselves, but they remember and they know and they care. And I had 3 doctoral students or really long period master students who stayed in the project and get most of the time also the salary. So this also turned the project quite expensive, but this was the method we used. And on the documentation, what I did, I was just not giving the credits, the study credits for the special assignment works if the documentation was not there. The only reason I gave the credits was documentation was there, it was assessed by peers, and it was available for all the team. If these were not fulfilled, there was no credits. A lot of people actually choose not to have credits then at all. But we also get some documentation out.
Thank you very much for the answer. So let's thanks again our speaker. And Thank you very much, Jaan, for inviting our audience to the Finnish conference. I had the opportunity to be there. It was below -10 degrees, I remember, but the talks were really interesting and the sauna time was really special during the workshop. So now it's time to go for the second keynote. And I would like to introduce our next speaker, Caius Reza, who is Head of Business and Marketing at Alba Orbital. He joined the company in 2019 after graduating from the University of Strathclyde in Glasgow, Scotland. At Alba Orbital, Caius is deeply committed to the company's mission to democratize access to space through PocketQubes. Overseeing strategic partnership and marketing initiatives, Caius has played a big role in the company's growth and impact. Having been involved in over 41 PocketQube missions launched with SpaceX and Rocket Lab, Caius has cultivated collaboration with estimated institutions like our university, the BME, Stanford University, Carnegie Mellon, and TU Delft, fostering new opportunities for space and STEM education and research worldwide. Caius, we are really happy that you could join us here in person in Budapest, and the floor is yours.
Thank you for the introduction. This is also my first time in Hungary. Very excited to visit Budapest. When I saw this conference being advertised online, I really resonated with the themes, which is all about education, international cooperation, and innovation, which is something I feel that is really pushing the PocketQube community forward. That is something that we very much are doing and agreeing with in our ecosystem, I guess. So my talk will be about PocketQubes and how they represent a new frontier in space education. So just to start off, we were founded in 2012 in Glasgow with the idea of democratizing access to space. So Glasgow, surprisingly, is actually Europe's biggest satellite manufacturing space out of anywhere in Europe. We've got companies such as ourselves, which is Alba Orbital, Clyde Space, Inspire, as among many others. And we are leading there, again, a small population, similar to Finland, which is 5 million people. And so we are the world leading PocketQube rideshare provider. So PocketQubes are, I'll touch on to what they are in a minute, but we've launched over 41 satellites now, with another 6 going to launch with SpaceX in Q4 2024. And from there, we have been working with Rocket Lab as well, so you can see our PocketQube deployer there on our third flight, I think that was. And we're also Y Combinator backed, which is basically the world's most prestigious business accelerator. You might recognize Airbnb, Dropbox, Reddit. Those are sort of alumni who come out of that program, so it shows that PocketQubes have really huge commercial value as well. And what we want to do is really build and enable turnkey constellations for folks. So just to talk a bit more about what we do, we are a completely vertically integrated company, meaning we are able to do everything end to end. So that helps people we work with as well, as they can sort of jump into our ecosystem as well. So we've got the Alba Connect, developed by Andy over here, who's with me today. And that's based in Berlin. We also provide the satellite platforms, Unicorn 2, as well as the rideshare services that you can see here. So first of all, what is a PocketQube? Just to keep things simple, they're satellites that can fit in your pocket. So they're very much like CubeSats, except a lot smaller. Built using sort of components off the shelf. They were proposed in 2009 by a professor called Bob Twiggs. So Bob Twiggs was the father of the CubeSat, but at the time, those CubeSat launches were rising. Originally meant to be, for students and everything. The cost for one new CubeSat was like 80,000 to 100,000 per launch. So by reducing the form factor to 5 by 5 centimeters as opposed to 10 by 10, it means you could, dramatically reduce launch costs to around 25,000 euro for something that's like a 1p, one pocket. And use cases range from all sorts, educational being something that we're focusing on today, to large-scale commercial constellations like how we're doing, as well as like telecoms and things like this. So just for you to have an example, of, the different Massats might have been mentioned before. But yeah, Hungary's first satellite, launched in 2012, and this is also SMOG-P, which is also Hungary's first PocketQube as well, that we had the privilege of working with Tibor and his team and András and everyone here. Yeah, so from here really, I mean, there's a lot of advantages to PocketQubes, of course, which I'll touch on later, but just to show you a comparison of like the kind of scale of satellites that have been going in the past. We are in the picosatellite range, which is basically satellites from, this is a bit off, but the standard, PocketQube standard says is around 250 grams to just under 1 kilogram. So anything ranging from 1P to 3P, that will show in the next slides. This is the nano satellite there, the 10 to 1 kilogram, that's an example of a 3U, just to give you context. That's from Planet, but you'll also see an ICEYE satellite, which Jaan has talked on in the microsatellite class. So from here, you can see the sort of different sizes that's proposed in the PocketQube standard. So the PocketQube standard was proposed in 2018 by Alba Orbital ourselves, TU Delft, as well as a company called Caius. And that really, if you want to look into building your own, really sets out a lot of the mechanical standards, as well as like others. But it is a bit limited, so it does need some updating. But if you want to look more at the electronics side of stuff, there's PQ60 documents, PQ9, PQ9-ish. But yeah, the thing about this is obviously it's enabling a lot of countries which would not have otherwise been launching satellites, would not otherwise be starting their own space programs. So for example here, the small one that you see on the very, depending on my side, right, is a 1P developed by Pion, one of our customers who came from Brazil. And that's actually Brazil's very first private satellite that launched with us in 2022. So Brazil had not had its own private satellite until then. It was just, something that was reserved only for like government agencies. So just to go back into history with PocketQubes, they did have a bit of there are sort of levels that go into satellite development, making it mainstream. And it started off very much on the amateur side of things, amateur university for education. And so these were the first satellites ever launched, with the first 4 that were launched in 2013. And they were quite basic missions, to be fair, but the one that I'm going to focus on is the $50 sat. So that was a 1.5P satellite. So $50 sat was fantastic at a lot of things. It wasn't supposed to be anything complicated. It was just meant to show the feasibility of a very low cost satellite that could be introduced to classrooms around the world. The name is a little misleading. It's more like a £125 sat. Don't know what that is in dollars. But yeah, the primary mission was to, in fact, demonstrate that this can be done at low cost without crazy requirements. I mean, it was built in a garden shed. And yeah, it was developed again by Bob Twiggs at Moorhead State University with 3 other radio amateurs. So it was only expected to operate like for 2 months in orbit, but it worked really quite well with the basic requirements it had, just like a amateur radio satellite for 20 months. So this paved the way forward for a lot of universities, a lot of people wanted to take it on. So it went on from PocketQube standard, kind of went on from the amateurs to universities saying, okay, cool, we can use this to teach the next generation of satellite engineers. So we moved one level up. So we've demonstrated they're cheap. We can launch them. They're good for education. Okay, cool. They're small. What can I do? This is something that's been rapidly evolving in the field. There's now been around 80, maybe more, of these satellites launched now, with a lot of like open source projects and such. But their use cases actually are starting to vary quite a range. So I really like showing this picture from our first launch. This is the Alba pod with the first satellites that we had ever put into orbit, the first 4 of 6 that we launched. So the 2 here I'll come on to talk about later, but they're from this very university, SMOG-P and ATL1. They were used for spectrum analyzing. Spectrum monitoring analyzing, and the white one was a high school project for like an Internet of Things demo, and the one on the very edge, that's from a German/American startup called MyRadar. So you can download their app, but they're basically looking to have their own satellite services for weather applications, basically warning their users of when the next storm might be approaching and such, especially in Florida, which they are based. So yeah, out of those use cases, today we're certainly going to focus on education. So what are the advantages here? Obviously, we've highlighted the affordability aspect, but also gives classes who wouldn't otherwise have really good hands-on experience. And the fact that it's such a good collaborative environment, you are able to, the really good PocketQube projects don't just incorporate the engineering side of things, but they also maybe bring on some media students who are able to promote the project, get funding, some legal, maybe business students who are able to go through the proceedings of frequency allocations and things like that. But also it allows universities who are willing to do a program such as this rapid iteration, so they can go and launch their first demo, and if it goes well, you know, they can go ahead for a year or second year to go ahead and just keep building on the work that they had. And with that, they are able to maintain student motivation. I've had a lot of CubeSat team reach out to me saying, okay, cool, we have the funds for a CubeSat, but our guys keep graduating before they ever see it, and basically we just need to get this thing to space. So it's something that can be done in an academic year. And of course, space access. You know, CubeSats had opened doors for a lot of people, but it still wasn't available for everyone. And again, so you can see how I mentioned more countries getting to space than before. This satellite here was from Malaysia, and this was their first PocketQube satellite out there. They're not typically associated with launching their own satellites. But getting onto a really good educational use case are the guys here with the SMOG project. So Hungary's history before that was with MassSat-1 that you saw, launched in 2012 as a result of ESA's Fly Your Satellite program. But yeah, from there, the university are starting an almost year-on-year satellite program, and that's where SMOG-P sort of started in 2013, 2014. That represented their initial line of PocketQubes. So the university is doing a fantastic job with this. I'd say they're the world-leading PocketQube academic team there is at the moment. So you can see up there the 5 satellites that they've launched so far, with another to come. So SMOG-P and ATL-1 were actually on our very first launch with Rocket Lab, and I did completely lift this slide from Tibor when he came over to join us in Glasgow, because it did show some good work. But yeah, I'll just tell you a bit about SMOG-P. So SMOG-P is a 1P satellite, 5 by 5 centimeters, and from there, yeah, like I said, the project started in 2013, and its primary mission was to measure electrosmog pollution, which is like electromagnetic waste, you know, being radiated into Earth's field. And it had done a really successful mission there. It hosted a DVB-T spectrum analyzer, as well as a total ionizing dose payload as well. So this was developed alongside another satellite called ATL-1, which also did the similar mission, but hosted an in-orbit demonstration for a thermal material. So here's the actual integration, hoping that the video works. Okay, I'll need to save the video for another day. But yeah, you can see us, this is out in 2019 at our very first launch. So this was on Electron's 10th mission, which was running out of fingers. They were testing the reusability of their booster stage, I think, at this point. But you can see some of our team hard mounting the Alba pod to underneath the rocket fairing. So that had the satellites that I mentioned on board. So there's a lot of successes to take away from the project. They successfully created the world's first interactive map of global electrosmog pollution, and deorbited at the end of September 2020, which is intentionally short just to get the mission done. That's the first stage. We had launched a bit lower than 520 kilometers, maybe around 400. And yeah, BME established the Space Engineering Master's course not too long after, and like I said, it's the world's leading academic PocketQube program. So the results really speak for themselves. The satellites would scan the Earth's surface about 2 times per day, and they managed to collect this not very long time after the launch. So at the end of the project, this is the results. So this is the estimated radio pollution in space of the altitude of 320 to 420 kilometers. I won't go into too much technical detail, as the guys who built the satellites are here in this room. So job well done from the guys. You can see them in our labs with the integrated payloads. Yeah, so not long after that, they went and launched SMOG-1, which again held a very similar mission. That was launched via Soyuz. The only thing there is they were, again, reiterating quickly which the PocketQube standard allowed them. That was just in 2021 that they launched. And they even added deorbiting tech, so they can demo that out. But in the spirit of collaboration, they've now launched MRC 100, which is very much an advanced 3P satellite from a university, but it also holds 5 other payloads from different universities across Hungary. So this mission had a camera on board and was also built to monitor. It's still part of the SMOG series, but is monitoring a wider range of frequencies. Yeah, so again, I did have a video here of the integration, but if you do check out, it is very well integrated. It's very well documented. You can check out the build process, the launch, and the integration process. And here's a video post-flight, but again, it doesn't seem to be working. So the one to our very left here, that is the MRC 100 3P in orbit, and that was joined us on our 5th launch in June 2023. And some successful images that they got from space, so you can actually see their antenna deployed in the shot. So now the PocketQube standard, getting it off the ground, no pun intended, was a bit of an uphill battle. People were just like, okay, CubeSats, these things are toys compared. But the more and more people came on board, they got to see more data. So we moved from the amateurs demonstrating it can be done cheap. It went to the universities showing, okay, we can now provide the science. We can now provide, actual data from space. So we've worked with Stanford, TU Delft, Carnegie Mellon University, as well as other universities across the world, in Asia, Turkey, and there's even some in Africa coming on board soon. And even now, they're being very much recognised for the educational value as well. So after years and years of trying to convince ESA this is a good idea, they finally did it this year. The first PocketQube missions were selected. This group is from Spain and this group is from Italy. But there was also like a Hungarian university in this as well. But okay, great. It's got educational values. It's good at a university level, but it's not just for universities. It's something that is opened access for even more people than that. So on that very same flight, we had ROM2, which is Romania's very first high school satellite. You can see that here. So that's currently still in orbit, along with MRC 100. But this tiny satellite had a huge impact in Romania. From the times I've visited, it's definitely been different from when I had first went over. So it was made by a group of like 15, 16-year-olds, and there was no teacher direction. Basically, they did it for themselves. And yeah, when I went out there, Romania had only ever launched one satellite. It was a CubeSat that had failed. It took them about 10 years to get to orbit, from what I hear. And from there, they spent an obscene amount in the hundreds of thousands to get this satellite to orbit. And that sort of killed the appetite out there. But when I went back, they saw that this satellite was functioning the way it was intended. After the kids had only spent 9 months designing it, 9 to 10 months designing it, and it got to orbit for €25,000. Just a few short months later, the Iranian Orbital Mission 2. And that's those kids there. You can see it integrated with MRC 100. But yeah, it was just such a huge inspiration for a lot of Romanians. You can see this is the world's first high school PocketQube competition. They had people from all over Europe come, about 30 to 40 teams, I want to say, competing to build their own PocketQubes at various different levels, which was fantastic considering the appetite before. But a lot of what Jaan said, it's more than just about, okay, we launched the one satellite. It's more than just, okay, cool, we've got these capabilities now. If you give the tech to kids, to the next generation of satellite builders, they'll go and do something with it. So yeah, a lot of these went to go and do space enterprises afterwards, after being in the classroom. So, for example, Innova Space here, that was just led by a teacher who came over to visit us in Glasgow for a PocketQube conference, got inspired, built their first 1P as a school, first Latin American high school to do that. After that, Argentinian government said, okay, cool, maybe there's some use cases here. and they went off to form an IoT satellite company, which has been taken off very well. And similar things happened. I mean, that white satellite that you saw in the pod earlier, they've now developed to be like a 20-man startup as well. Hello Space was developed from a CANSAT project at university to the first PocketQube in Turkey to now launching their own constellation of near to 100 satellites soon. And up here is SpaceIn, which is again a university project turned IoT startup. And the use cases really, there's PocketQubes allow for a lot of novel use cases here, and commercial ones as well. So personally, with what we're doing here, we're focused on Earth observation. We see a huge niche there with our Unicorn 2 platform. We raised funding from Y Combinator to do near real-time Earth observation. We've already got some customers on board, like the US National Park Service, and a lot of insurance companies insurance tech companies down in London. So in terms of future developments, all I can really attribute that to is the word scale. That's what we're looking to do. So we've now moved into our new facilities, which is the world's first PocketQube factory in Hillington, still in Glasgow. It's double the manufacturing space, all under one roof. And yeah, we're looking to make like an assembly line for these Pico satellites. We're also looking for more talented satellite engineers. So if you fancy coming to join us, Andy's here, our head of manufacturing and design. We're looking for quite a few folks. But we also want to help with the next generation of builders, again, sort of scale the amount of people building them. So we're pairing with MaxIQ, which is a company originated in South Africa but moved to America. I've got a lot of connections in the sort of STEM fields there, as well as Africa. So the idea is very similar to what MRC 100 did. You know, there would be one lead institution looking to build their first satellite, and we want to make it a lot more accessible for school teachers to show this to their students. So we will have like payloads they can choose from, and in that kit, you know, we'll be able to send it to space with 8 high schools supporting that primary institution, whether that be a university. And basically, we put that together as a complete package where high schools can join for like 10 grand each. And from there, again, we're looking to scale the level of constellation deployments as well as for universities. So this is where our 96p deployer comes. So it's very much like our 6p deployer that we've been working with, except, you know, it's a lot strapped together, so we can bring a lot more satellites online, which is very important for a constellation like ours, as well as the IoT guys. And there's a lot of potential spin-offs that can be done with that, like a space tug, for instance. But if PocketQubes, you know, is something you have been really interested in, we do host an annual PocketQube conference as well. This is the world's biggest conference focused on PocketQube developers. So BME actually did the keynote a couple of years ago. They joined us last year. This is Yasser from the SMOG program. But yeah, we'll have panels, exhibitions, talks, poster sessions, networking, and tours of local space companies as well. So you can type in www.pocketcubeworkshop.com or PocketQube Conference and you should find it. And again, I've been Caius at Alba Orbital. If you have any questions for me, just let me know.
Thank you very much for this excellent talk, and I really appreciate that we could see some Hungarian examples as well in your presentation. We have time for a quick question. Yes?
Thank you for a wonderful talk, and there's some wonderful data. I have one technical question. CubeSats were first 20 years playing with the problems with attitude systems. How it is with attitude systems for the CubeSat or PocketQubes?
So basically, you could do a couple of solutions. In our unicorns, we have got an ADCS, 3-axis reaction wheels, and there's also ways to do it with magnetorquers as well. That's basically the most popular ways to do it. Yeah, that's basically how I would answer this sort of. To varying degrees. Some projects a lot better, some projects not so much. But yeah, there's a few different ways to do it.
Thank you. Do you have any burning question from the audience? Yes? And please repeat the question for the...
Do you know what the primary payload for the ROM2 was?
So the primary payload was basically to be like a radio repeater kind of thing for radio amateur satellites, but it did have like a low megapixel camera on board, and that's what they looked to develop. So basically with ROM2, it was just to show that students like them could do it, and the payloads did work. I think they did struggle to download their first picture, but with ROM3 they had a lot more improvements. So ROM3 was just basically slightly bigger, so they could have bigger batteries, more efficient solar panels, and they flew a better resolution camera on their third one. They are looking to move towards ROM something this size next time, and surprisingly again they are looking to be a startup as well. I think they've got some funding from Romanian government to become a hyperspectral constellation, but yeah, it's crazy, these kids move fast.
Thank you. So let's thanks again our speaker for this excellent talk. And now it's time for the poster highlight talks. As we announced in our program, there will be roughly 30 poster presentations today, and we would like to allow the possibility for every poster author to present his or her work in 1 minute. So with this, I would like to ask every poster presenters to stand on that part of the room. So please go there. And the presentation of the posters, I mean, the order will be the same as we announced in the program. My colleagues from the BME Cosmos College for Advanced Studies helps the authors to line there. And to ensure the smooth process, I will handle the mic to every poster presenters. I have a timer with me for 1 minute, and it's really hard to present your whole work in 60 seconds. So this is just to make the announcement for the posters, which can be found in the coffee break, which will be right after this poster highlight talks. So with that, the first poster is by Panta Shishakant. He cannot be with us here in the room, so let's go to the second one.
I would like to greet everyone. My name is András Mihály, and our research title is Fast Entanglement Routing in Satellite-based Networks. In our research, we've developed a novel routing algorithm which can be parameterized with the coherence times for quantum memories. In our algorithm, we take an initial representation of a satellite network, which is a time-varying graph. Then we transform it into a directed graph, which leads to a faster routing times and modularity in choosing our routing algorithms. With the use of our algorithm, we could create entanglement routes that could span the whole globe with even 100 seconds of quantum memory coherence times. Thank you very much.
Thank you, András. The next presenter is Orsolya Meier.
Thank you very much. Oh, can I start? Yes. So welcome everybody, I'm Orsolya Meier, and our research with Milan Fehér and Éva Domokos-Szabolcsi is about circular food production in space environment and insect protein production by supplementing green biomass in feed. We used green pepper, alfalfa, and duckweed, and we mixed them with wheat semolina. We used this mixture as a forage for yellow mealworm larvae. During our experiment, we could measure the production parameters and also the composition of the larvae, and we reached the highest crude protein content with the alfalfa group. If you are interested in the long-term space missions food supply or circular food systems or alternative protein sources, feel free to ask during the poster session. I'm happy to share my knowledge, and thank you very much for your attention.
Thank you. The next is by Anna Fehér.
Welcome everyone. My name is Anna Fehér, and my research is determining the thermal properties of heterogeneous materials. But we are using heat pulse experiment to determine the thermal diffusivity of materials. But when we evaluating these experiments, we are not using the well-known Fourier equation. We using extended heat or thermal equations because the Fourier equation can so the thermal diffusivity of the materials can have a huge error if we evaluating with the Fourier error. So we can show that we can do better evaluations with extended equations. So thank you.
Thank you very much, Anna. I would like to call the next author. Ákos Kereszturi.
Hello, thank you very much. I did this with my colleague Bernadette Pál. This is about, we would like to find out how the spectral shape of an asteroid look like if it is space weathered, so heavily solar irradiated and other space weathering effects influenced. So with Atom Key we are making artificial space weathering of meteorites, and we would like to see which are the last remnants of mineral fingerprints that can be visible in the spectra. So if there is a satellite that goes to an asteroid and record the spectra, we hope we'll be still able to identify which kind of minerals are still there, but heavily irradiated and destroyed, but partly still visible. And it also supports the identification of determination of spectral bands of infrared detectors.
The next one will be by Máté Krezinger.
Hello everyone, my name is Máté Krezinger and I'm a PhD student at Utvary University, currently doing my 4th year in astronomical studies. And the poster I would like to present you today is about high redshift radio quasars. So these objects are actively accreting supermassive black holes, and they are located at high redshift, so in the early universe. They are launching high relativistic plasma jets, which we can detect in radio bands, and with the unique technique of very long baseline interferometry, we can achieve the finest angular resolution possible in astronomical observations, millisecond angular resolutions. So we selected 10 radio quasars, which we observed with this VLBI technique, with the European VLBI network at 1.7 gigahertz. And we collected data from space-based observatories like Gaia, WISE, or Chandra. And combining ground-based and space-based observations, we can reveal much more information about radio quasars. So feel free to join me at the poster Thanks.
Thank you very much, Máté. The next one is by Kinga Tamási.
So, ladies and gentlemen, thank you very much for the opportunity. At first, let me introduce myself. My name is Kinga Tamási, a passionate space materials engineer from the University of Miskolc and the Unispace Hungary program. And I would like to present our happiness work from the university with our tiny, diverse team, because we had the same dream. Let's go to the space and to build something there on the moon. That was the reason that we have started our research with the glass foam-based insulate materials. And that was the reason that we have performed the classical thermomechanical and the electrical performance tests. And so we are really satisfied with our results. And it looks like that composition will be suitable to the terrestrial life on the moon in the future. Hope so. And thank you very much your support and our team members' support and the university and of course the Hungarian Astronautical Society also. So thank you very much. Please enjoy our poster section, and if you have a question, please don't hesitate to contact us.
Thank you very much, Kinga. The next presenter is Gergő Mezőhegyi.
Hello, good afternoon. This is Dr. Gergő Mezőhegyi. I'm a project manager at C3S LCC. MAUA is a 3-year science mission conceived to study stars in our galaxy. M-dwarfs are currently of great interest for both astrophysics, planetary and also astrobiology communities due to the prevalence of small planets within their habitable zone. The partly European Union funded MAUA project aims to build for the first time a ready-to-launch CubeSat in a rapid time scale with the ultimate purpose of observing such stars via ultraviolet spectroscopy. The satellite is being built by an international consortium. Scientific work is led by Blue Skies Space. The CubeSat technology is delivered by C3S from Hungary. Already done. Okay. Maybe next time for a plenary session. Thank you so much. Looking forward to see you at the poster.
Thank you, Gergő. I know that it's really hard to make it in 60 seconds, but this is what we can offer. Yeah, the next presenter will be Kitty Berényi.
Hello, my name is Kitty Berényi and I'm from Hungarian Aalto Space Research Group and also from Hungarian Institute of Earth Physics and Space Sciences. My poster is about a multi-instrument analysis of ionospheric storms driven by interplanetary coronal mass ejections. We used Digisond data, GNSS total electron content data, swarm and time satellite data for our analysis. Our main conclusions were that with our new method, we can track specific ionospheric structures during geomagnetic storms. For more details, please come to my poster. Thank you.
Thank you very much, Kitty. The next presenter will be Pál Gábor Vizi.
I will be very short. You can see the title, and I hope we will meet at the poster.
Thank you for this brief presentation. The next presenter will be János Gaskó.
Good afternoon, everybody. Almost János Gaskó. My name is Daniel Fátai. No problem. So we have developed a GNSS reflectometry-based, low-cost, fully automatic measurement system that is capable of measure water level and other open water like river and lake water parameters based on GNSS reflectometry, which works on the principle that signals from the GNSS satellites can reach our receiver from multipaths and causing interference, and by analyzing this interference we can determine the parameters I mentioned before. Thank you.
Thank you, Daniel. The next presenter will be Richard Tomka. Instead of him, Ákos Kereszturi.
Thank you. Richard is my PhD student, but he is late, so I will take this. Actually, we are working on for the mission called CP22, which is under the NASA-ESA collaboration and part of Artemis project, which will land at the southern hemisphere of the moon. We'll drill down to 1 meter depth and hopefully find ice. And we supporting the landing site selection with GIS. Actually here, specifically we developed the method to estimate how thick or thin is the ejecta blanket of different craters and how they are arranged, and this can be simulated with GIS. And come and see the poster.
Thank you. Yeah, this is why I like this poster highlight session, because we try to prepare, as a chair, try to prepare to announce the speakers, and there are always surprises for even me. But the next presenter will be perhaps Péter Püspöki.
You're welcome, everybody. My poster is about the MRC-100 and its power system. This is our latest and most complex satellite. It has over 30 subsystems. So the power system had to be designed to be able to control this complexity, and therefore it has a distributed intelligent system. So practically every subsystem has a limiter switch, which includes a microcontroller, and it can be controlled by the central power unit, and it also collects telemetry data from the subsystems.
Thank you. And we have another poster from the group of Kitty Berényis.
My second poster is about T-Force Horizon Europe project and the Hungarian and the work of the Hungarian group. The T-Force project is about the forecasting of the so-called traveling ionospheric disturbances. We use machine learning-based models and also climatological models for the forecasting. And for more details, please come to the poster.
Thank you, Kitty. The next presenter will be Benedek Mihály Csara.
Hello, good afternoon. My name is Benedek Csala. In the case of satellite and terrestrial radio connections operating in the millimeter wavelength range, fading phenomena is primarily caused by precipitation, especially rain, during the processing of measurement data. Identifying fading events is particularly difficult, which is necessary for the production of accurate statistical data. The measurements of the received power level were taken on a satellite and on a terrestrial radio link. The correlation between the different links were analyzed, and also the cumulative distribution of attenuation were calculated. Thank you.
Thank you, Peter. The next poster is by Máté Sarka.
I'm from Institute of Nuclear Research, Atomki, and we have a few particle accelerators. So we made some advancements on the biggest one, the cyclotron, and did some solar particle event simulations. To test the robustness of our system, we used very sensitive samples, living systems, muscle cells, pharmaceuticals, and fungi. Actually, if you want to know more, find me at poster 18. And spoiler alert, the cells survived the irradiations.
Thank you, Máté. The next presenter will be Bence Csaba Kovács.
Hi everybody, I am Bence Kovács and I am from Team Teller. We are a Hungarian student team and we are participating in a Swedish-German international student program called Rexus. Hungary has a great history and a heritage of radiation detector instruments in space, and with Project Teller we are willing to continue this line. We are using a special Geiger-Müller module and the scintillator module. If you have any questions or are you interested in our project, we are welcome you all to visit our poster, and we are happy to answer your questions. Thank you.
Thank you. The next presenter will be Bernhard Seifert.
Good afternoon, everybody. My name is Bernhard Seifert. I want to introduce the simulation framework CubeSim, as you see here. I think you all know the issue when you're developing small satellites, CubeSats, PocketSats, and so on. You need to have extensive testing capabilities like solar simulators, Helmholtz coils, and so on. We did another approach that we are developing a software simulation toolkit where you can access, for example, your sensors, actuators, as you would do it later on in the firmware of the OBC. But all the sensor signals are delivered in an abstract way, so simulated. And this means that you don't need all these testing capabilities and can develop your system like in software. And you can also extend this framework as you like. It's open source, it's freeware. And I'm happy to answer any questions afterwards if you join me at the poster. Thank you.
Thank you, Bernhard. The next speaker will be Vilmos Steinman.
Hello, welcome everyone. My name is Vilmos Steinman from Aalto University and Konkoly Tege Miklós Observatory. My research is about a complex hydrological and landscape evolution model for arid and Martian environment. And the main target is for the Mars because I want to help for the future rover mission to target and estimate the source of the accumulation deposits on Mars. Any further question, you are welcome at my poster. Thank you so much.
Thank you, Vilmos. The next presenter will be Kitty Ola.
Welcome everyone, I'm Kitty Ola and I work with László Bacsárdi, and our topic is the role of the entanglement in development of satellite-based quantum internet. Nowadays there is a growing trend on the using quantum technology in computing or communication. These includes development of the future quantum internet, not just the only optical fiber. Of course, we can use a satellite-based communication system. In order to perform quantum communication in a large distances, we need to use the quantum memories. So that's why our research topic to investigate, to use different type of quantum memory on satellite for entanglement-based communication. If you are interested in more details, please visit our poster. Thank you for attention.
Thank you, Kitty. The next presenter will be Ádám Dobai.
Thank you. Welcome everyone. I am Ádám Dobai and I will present the work that we did. We are part of a competition team called BME Suborbitals, and we are developing sounding rockets, which allows us to basically experiment in the uppermost troposphere under high acceleration, high radiation and low pressure conditions with return capabilities. The currently under development CubeSat of our team has the traditional onboard computer, electrical power system, communication panel, and payload layout. Here we present some of our latest advances of our payload experiments, including a monochromator, also an orthogonal frequency division multiplexing or OFDM channel characterization. We also aim to investigate the rocket travel-induced effects on the Caprinopsis cinerea mushrooms sporulation, and we also implement a horizon detection camera with traditional cameras available for everyone. We are looking forward to meet you here at our poster stand, and thank you for your attention.
Thank you, Adam. The next speaker is Gergely Márk Tölgyesi, and I just would like to remind every speakers that since we have online streaming, we ask everyone to speak close to the mic.
Welcome, ladies and gentlemen. My name is Gergely Márk Tölgyesi, and I'm a part of a research project which aims to develop solid fuel rocket engines for suborbital rocket applications. Determining design attributes of a solid rocket engine is particularly hard, mostly in the preliminary design phase. So we developed a novel method of doing just that. If you're interested in this, or you just find solid rocket engines a cool thing, I would like to invite you to check out our work at stand 24. Thank you.
Thank you very much. The next speaker will be from Sashat team.
Thank you very much. Welcome, ladies and gentlemen. I'm Máté Krezinger from the SASAT Interdisciplinary College for Advanced Studies. With my partner, we are from Győr, from the University of Győr. Our poster will highlight why we use two sets of antennas, why our antennas are on the top of the dormitory, and what were our challenges we faced throughout our mission of setting the radio communication with the ISS. Thank you very much for your attention.
Thank you. The next speaker will be Zoltán Jécsay.
Good afternoon. I'm from the Center of Energy Research, Radiation Protection Laboratory. We organize the Class Space project, in which we organize teams of students from primary and secondary schools to develop and later implement scientific experiments parallel with the astronauts on the ISS. Thank you.
Thank you. The next speaker will be Bence Kertész.
Dear ladies and gentlemen, my name is Bence Kertész. I'm from the University of Public Service. In my research, I analyze the lack of European space launch capabilities and its effects on the European strategic autonomy in space. Since last year summer, Europe has lost its space launch capacities and autonomous access to space, which fundamentally threatens the European strategic sovereignty in space. This research analyzes this case and also defines three major challenges to tackle in this sector. These are commercialization, creating space launch capacities for crewed missions, and creating reusable space launch vehicles. These are the common challenges which are needed to be tackled, and these will determine the future of European space sector and strategic autonomy. Thank you for your attention.
Thank you, Bence. The next speaker will be Tibor Hegedűs.
Hi everybody, I'm Tibor Hegedűs from Bioobservatory of the University of Szeged. We, together with the Hungarian Meteoritical Society, maintain and operate a 6-station all-sky camera network all over Hungary. And in our poster, we present you some details of the system. and the most interesting cases from the last year, 3 or 4 fireballs, and the preliminary analysis results, velocity curves, light curves, and ablation model of these fireballs. We are looking for future cooperational partners, so I would be very happy if some of you would be interested to cooperate with us for the future extension in the space awareness program of this camera system. Thank you.
Thank you, Tibor. The next speaker will be Benedikta Redring.
Welcome everyone, my name is Benedikta Redling. I'm from Széchenyi István University from Győr. Through my presentation I would like to show you a small group of our SESAT team taking of pictures from weather satellites.
Thank you. The next presenter is also from Győr, Barnabás Zoltán Baranyai.
Thank you. Welcome everyone, I'm Barnabás Zoltán Baranyai, student of electrical engineering at Széchenyi István University. In my poster I would like to present the first module by SESAT that reached the space. My poster describes the manufacturing process, the testing methods, the launch, and the post-launch tasks, such as how to receive the module signals. Thank you.
Thank you very much. And last but not least, Dóra Borbála-Kovács.
Good afternoon, everyone. My name is Dóra Borbála-Kovács. I'm a master's student from Budapest University of Technology and Economics. Today I would like to show you my poster titled Daytime Optical Background Radiation. In this research we delved into the relationship between quantum communication and background radiation. The device we used was developed here at our university, and it enabled us to conduct precise measurements on 4 different wavelengths. So if you're interested, I'm looking forward to answer all your questions. Thank you.
Thank you very much, Dora. This concludes our poster highlight talks, and I was really amazed by these 60 minutes pitch presentations. So I will suggest the leadership of our university to change how we are teaching our students and changing our structure for 90-minute classes to 60-second classes to our students as well, and see how the education could work in that way. But anyway, let's begin another round of applause all of the poster presenters. And with that one, we are almost finishing this first session. I just would like to make an official announcement. We already sent out that we had some slight changes in our program for tomorrow, because we were happy to announce that we can offer you another highlight talk from the USPA, the European Union Space Program Agency. So this highlight talk will be tomorrow, just right after the last technical talks in the morning session. So this will be an online highlight talk by Kristina Giannopapa from USPA. And with that one, it's time for closing this first session. We will have a coffee break and poster session for 45 minutes, and we will continue in this room 4:45. Enjoy the coffee break.